A cup falls off the table. The blow is brief, but its result is devastating. Dozens of pieces scattered on the floor. Some are large, others so tiny that they barely see each other. Why don't you just break into 2 or 3 pieces? If you like this kind of content, don't forget to subscribe and give like. The science behind object fragmentation is fascinating and invites us to explore a subject that seems trivial, but that contains a surprising complexity. According to a study published in Physical Review Letters, there is a mathematical law that describes how objects are fragmented when broken. This research, led by physicist Emmanuel Villermont, proposes that objects tend to break in the most random way possible, but within certain physical limits. This finding applies not only to solids such as glass or dry spaghetti, but also to bubbles, drops of liquids, and even archaeological fragments of stone tools. Chaotic also follows rules. When analyzing how the sizes of the fragments are distributed after a break, Villermont and his team found a pattern repeated in many materials. Most fragments tend to be small, and very few retain a large size. The explanation is based on a principle known as maximum randomness. This implies that, among all possible ways of breaking, the object chooses the most disordered, provided that it respects certain physical conditions. The most striking aspect of the study is that the distribution of fragments does not depend on the material, but on the shape of the object. Objects of different natures generate fragments with very similar size patterns when their shape is comparable. Villermont reviewed data accumulated over decades on fragmentation of various bodies. He observed that the proportion between large and small fragments followed the same statistical rule in all cases. To illustrate his theory, Villermont conducted a simple experiment, dropping weights on lumps of sugar. The higher the weight was dropped, the more numerous and smaller the resulting fragments were. Despite the scope of this law, not everything follows this pattern. There are situations in which fragmentation is regular, such as the breaking of a stream of water into drops of the same size. These cases have dominant mechanisms that modify randomness. Knowing how things are broken has implications in multiple fields, from the mining industry to archaeology. Understanding fragmentation helps us to optimize processes and read clues about the past.